Okay guys, I'm going to do a little bit of quiz review with you at the beginning, and then I'm also going to go over some of the homework questions, some of the proofs. So the proofs that I'm going to do with you are these guys here. 4.2b, it's number 17. 4.3a, it's 12, 14, and 28. And I will try and keep this short and sweet and to the point so you can get going on your other stuff. For quiz review, the first couple things you're going to need to do is identify if triangles are congruent using the different postulates we've talked about. So we have done at this point SSS, SAS, ASA, and AAS. Those are your only options. If you don't see one of those, you need to say not enough info. So if you look at this first one, you have an angle and an angle, a side, a side, a side, a side. So your only option here is it might be SAS, but if you look at the setup of it, it's not the included angle, right? If it was going to be the included angle, it would need to be those two. So this is actually donkey theorem, which we don't swear, so it's not. So for this one, you would have to say it's not enough info. Second one here, you're given two angles, but you also know more information, and whatever you know to be true, you're allowed to use. So for instance, I know that this segment, we'll call it AB, is congruent to itself, right? AB is congruent to AB because of reflexive. So if I look at my setup, I have angle, angle, side with angle, angle, side. So we would call this AAS. Third one, oh, I forgot to mark things. If I gave you this, okay, so you're given that picture, but we also know that vertical angles are congruent, so that means these two angles are congruent even though they didn't mark them for us. So then we have a side, an angle, and a side with a side, an angle, and a side. So that one would be SAS. Okay, so it's just naming what you have, and it's not just based on markings, it's based on, if you see vertical angles, if you see reflexive, that type of thing as well. Okay, so going over some of the homework. 4.2b, number 17, they give you this proof. They tell you X is the midpoint of AG and NR, and you have to prove the triangles are congruent. So your first step is always going to be your given information. So you'd put that here, call it given. Your second step on this one, look at what they tell you in the given. They tell you X is a midpoint of both of those segments. So technically, if X here is a midpoint, then AX is congruent to XG. And we can say NX is congruent to XR. And you're allowed to put those in the same step because they have the same reason. Remember I said whenever there's a word in your given, like midpoint, you're going to use the definition of that. So the definition of a midpoint is what tells me those are congruent. Okay. Third step, when I look at this picture, I can also see that those two angles are congruent because they're vertical angles. So you just need to make sure you name the angles correctly. So AXN congruent to GXR, okay, by vertical angles. And make sure you're marking as you go, because now that we've marked, you can see side, angle, side with side, angle, side. So we can say what they asked us to prove, which would go here, by SAS. Okay. Next one. 4.3a, number 12, looked like this. They give you that QR is congruent to TS, so mark that as you go. QR congruent to TS, and they tell you QR and TS are parallel. So we'll mark those parallel. Step 1, always you're given. So that information's going here. And we call it given. Step 2, you have options here. There's not like one thing you have to do right now, but I always think it's safest to start with your given information. What does that lead you to? So if you look at this statement, QR parallel to TS, the reason, or what it leads you to, them being parallel, is alternate interior angles. Remember, parallel lines often do that. So those two are alternate interiors. So angle RQT congruent to angle STQ by alternate interior angles. Okay, third step, I know QT is congruent to QT because it's reflexive. And remember to mark as you go, because now you see side, angle, side, with side, angle, side. So for your last step, you can say those 2 triangles are congruent by SAS. All right, number 14 on the second lesson. Given that V is congruent to Y, so mark that as you know it, V congruent to Y, and WZ bisects angle VWY. So angle VWY is this angle. They're saying that's getting bisected, okay? So step 1, take that information, plop it here, call it given. Step 2, look at your given, right? WZ bisects. That means that these 2 angles are congruent. So you're going to say angle VWZ is congruent to angle YWZ. And remember, when you see that word, it's because of that. So definition of a bisector. And then we know WZ is reflexive. So WZ is congruent to WZ. And you would say reflexive. You're fine. So then when you look at your setup, you have angle, angle, side with angle, angle, side. So we can say the 2 triangles are congruent, last step, by angle, angle, side. Okay. And last one. Step 1, always you're given. So you take this information, put it here, and then mark what you know. So AB parallel to DC and AD parallel to BC. Okay, remember parallel lines often lead us to alternate interior angles. So because both sets are parallel, we can say these 2. So BAC is congruent to ACD. And because they have the same reason, I'm just going to keep it on the same step, because we also know these 2 are alternate interiors. So DAC is congruent to BCA. And the reason for both of those is alternate interior angles. The other thing we know in this one is AC is reflexive. So AC congruent to AC by the reflexive property, which means when you look at your picture, you see angle, side, angle on both of them. So we can say these 2 triangles are congruent by angle, side, angle. Okay, that pretty much covers it for things you'll see on the quiz. There is a proof on the quiz, so walking through some of this, you are allowed to use SSS, SAS, ASA, and AAS. Keep in mind, whenever you prove triangles congruent, so it's triangle something here and triangle something, it's going to be one of those reasons. All right. Have a great day.